Welcome back to part 2 of blending and pasting images. So far in part 1, we've seen how to overlay images on top of each other by simply replacing values of the larger image with values of the smaller image for a desired region of interest, or ROI. But what if we actually only wanted to blend or replace part of the image? So these are the sort of operations we've done so far. We have on the left-hand side this image of a robot, and then we can say that's image 1. We have some secondary image. Image 2 is the OpenCV logo, and we know now how to overlay images on top of each other. And we can do this as well for images that are different sizes by simply selecting an ROI, region of interest, and then replacing the values there, or blending the values there and then adding those back in. So we're already comfortable with this. But what if we actually want to mask part of the smaller image? If we take a look back at this example, notice how the rest of that robot image becomes darker because of the black parts of the OpenCV logo. But what if I wanted something that looks like the right image there? I want to put the OpenCV logo without having to reference any of that black material. This is then going to need 3 stages. We need the first image that we intend to paste on, and then we actually need to build a mask. And the mask is only going to let certain parts of the image 1 filter through when we actually then paste it onto image 2. So that's what we're going to discuss right now. How do we actually create these masks? And then how do we only let certain parts through of the smaller image onto the larger image? So we're going to explore the syntax for these steps. Keep in mind, this syntax is actually really complicated. This is not one of the strong suits of OpenCV. It actually takes a little bit of code in order to get things rolling, and it's not quite intuitive at first. Now, there are 3 really good supplemental links at the bottom of the lecture notebook for you to explore for other use cases. But in this case, just take it easy. We're going to create the mask. We really won't be doing anything like this throughout the rest of the course. So if you find it overly complex, keep in mind it kind of just is. And don't worry too much about understanding every single minute detail because we won't really be needing it for the rest of the course. With that being said though, it's a good idea that we explore the syntax here just to see the capabilities of masking with OpenCV. Let's get started. Welcome back. We're continuing right where we left off in the last lecture. Now it's time to blend together images of different sizes. We're going to start this all over again by reloading these original images. So I will grab over here image 1 and image 2. Just to make sure we don't have any of these overlay effects that we previously did. And then also what I'm going to do is run that resizing command. That way the do not copy is quite a different size and we can lay it on top of the larger image. Okay, so I have image 1, that's the larger dog backpack image, and then I have image 2. And in this case, they've already been color corrected. The next step is to decide where on the actual image do we want to blend in the do not copy. So if I take a look at the image 1 and run that, what I need to do is figure out a 600 by 600 space on this image of where I actually want the do not copy to be blended. And this is known as creating a region of interest. So an ROI, or region of interest, we're going to grab one from the larger image, essentially a 600 by 600 cube that I'm interested in blending the smaller image onto. I could come up here and do the same thing we did last time, just start at 0, 0. But instead, I'm going to show you how to do it if you wanted to paste it at the bottom right. So it's going to be a little bit tricky, but hopefully this math makes sense to you. What we need to do is figure out what are the actual dimensions to grab in order to grab this bottom chunk that is 600 by 600. So if I check image 1 shape, that's 1401 and 934. So on the y-axis, I have 1401. On the x-axis, I have 934. Which means I need to figure out my starting x offset and my starting y offset. And I can do that simply by saying the following. I'll say x offset is equal to 934, the very end of the x-axis here, and then I'm going to subtract 600 from it to bring it back over here. So we'll say minus 600. All we're doing is we're starting at the very end of the x-axis and then subtracting away the length of the x-axis of the smaller image. And we're going to do the same thing for y offset. Starting at the very end of y, I'm going to subtract away 600. And that's going to then allow me to calculate the top left corner that is 600 away from the ends of both x and y of the larger image. So that is my x offset and y offset for the bottom right corner, essentially the opposite of setting 0, 0 for the top left corner. Now what I want to do is create an ROI of the same size of the foreground image. The foreground image is simply the smaller image that is going to go on top. And if I check out image2.shape, notice it's again 600 by 600 by 3. So that means I can use tuple unpacking to reassign this. We'll say rows, columns, and channels is equal to image2.shape. This way we have generalized terms of rows, which is 600, columns, which in this special case, since it's a square image, also happens to be 600, and then the channels happens to be 3. There's 3 color channels there. What I want to do now is actually grab the ROI. It's a very similar process to what we did before. My region of interest is merely the first image, and I'm starting at Y offset, and then I'm going to go all the way to the end at 1401, because I'm grabbing right now the bottom right corner. And then I will go from my X offset that I defined and go all the way to that end, which is 943. So that's my ROI. If I show you my ROI and run that, that's the bottom right-hand corner of the image. Notice that it's just the bottom of that backpack. If I take a look at the original image, all I'm doing is I'm grabbing this bottom corner by finding out what my X offset is, minus 600, and then just going down all the way to the image because I literally calculated it by 600 off. Okay, and what you could do is in general, you could have subtracted the columns here and the rows there for this X offset and Y offset. So you could have done this shaping first. Now the next step is to actually end up creating the mask. And the mask is going to allow us to only grab that red portion of the do not copy. So we're going to come down here and let's make a new cell here. And what we're going to do is start off by getting a gray scale version of the image. We'll say image2 gray. And then what we're going to do here is say is equal to CV2 CVT color. We'll pass in the original image, image2, and we're going to convert it to grayscale. So we'll say CV2 color, and I believe it's already in red, green, blue. Then we'll say 2 gray. Okay, so we're going to run that command, and now I have that grayscale image. Let's go ahead and show it, make sure that worked out. And right now it's using Veridis as its color mapping. That doesn't really make sense in this case, so let's change it to grayscale. There we go. And what I actually need is the inverse of this, because right now this mask is essentially going to block out with black all the red material. So instead what we want to do is the exact opposite of this. I want to have in pure white what I want to show through for the do not copy, because remember, we're building out the mask right now. And in order to do this, we're going to say mask underscore INV, and we're going to calculate the inverse of this image. And the way we can do that is through the CV2 bitwise underscore not image to gray. So what this does is if you actually do shift tab here, it's going to calculate on a per element bitwise the inversion of the input. It's essentially going to invert this so that everything that's black is white and everything that's white is black. So let's try this out. We're going to run this. And now we should see if we say plt imshow the mask inverse, run that, and now we notice it's the opposite. And let's double check by changing the C mapping to be equal to gray. Run that, and now we see we have white space, so that's going to allow anything to shine through, which in this case is that red material that we want, that red do not copy. Now, unfortunately, if you notice right now, mask inverse, if we were to check the shape of this, it no longer contains color channels. And what we need to do is add in those 3 channels again so that the 2 arrays are compatible with each other. The way we're going to fix that is with a little bit of NumPy. We're going to import NumPy as NP, just in case we haven't done it already. And then what we'll say is white background. And there's various ways you could actually build out. What you could do is just say np.ones, make it have the same shape as image2, and then multiply it by 255. What you can also do is use a function that we haven't actually seen yet, but is really useful. It's np.full, and it's essentially going to take the step of ones times some value and do that for us. So all you need to do is for np.full, you just pass in the shape that you want, In our case, we want the shape of image 2, 600 by 600, and actually 600 by 600 by 3, and then you're going to decide what you actually want this full of. In our case, we want it full of 255. And then to make sure it works nicely, on certain operating systems, you have to say dtype is equal to np.uint8. So go ahead and do that. Often if you forget that dtype step, it actually won't produce an error or anything, but just in case, let's make sure we have everything in integers. So now I have a white background. So if I check out my white background, its shape is now 600 by 600 by 3. So all I did here for the npfull command, it takes in the shape of what you want the array to look like, what you want it to be full of. So if I actually check out white background, it's just full of 255 as integers, and then the data type. So we're going to make sure the data type matches the mask, so we'll keep it as integers. Okay, so that's our white background. And then what we're going to do is the following, and this one's probably the more complex command we're going to see today, is we'll say bk for background is equal to cv2, and we'll say bitwise OR. And what bitwise OR does is it calculates the per element bitwise disjunction of two arrays. So what that actually means is we're going to do the following. We're going to pass in source 1, source 2, and then the actual mask. So we'll use the white background for both source 1 and source 2. And then the mask we're going to pass in is mask underscore inv. So when you run that, your background shape is now 600, 600 by 3. And if we show the actual background shape, so all this ended up doing was now we have this do not copy the same figure across all three color channels. And if this doesn't make sense to you, this bitwise OR, which is essentially just grab these two white backgrounds and then put that mask on top of them, then what you could have also done is grabbed the original mask inverse and then just formatted it using NumPy 2 more times for the other two color channels. I recommend using this generalized bitwise OR operation though, just in case you have a more complex figure and you have more than just one color. But all this is really doing is we created a white background for all the color channels and then applied that mask to it. And when you apply that mask to it, now you have 600 by 603, where every single color channel now has this do not copy image. Next, what we're going to do is we're going to grab the original foreground image and place it on top of the mask, because right now this is actually still white. So what I want to do is replace that with the original image, which is red. And what I'm going to do here is the following. We'll say plt, or actually we need to say foreground is equal to cv2. And we're going to say bitwise OR again. And this time we'll do it with image 2. Remember, image 2 is the original do not copy. And then we'll say mask is equal to mask underscore inverse. So all this is doing is image 2 is our original image. And for all three color channels, all we're going to say is put this mask on top of it, which means when we actually run this and show it, the only things that are going to be coming out is what is in white, which in our case is the do not copy. So that aligns pretty much exactly with the red material. And this is how the mask is working. You create the mask, anything in white is what's going to be allowed to shine through, and then you use this bitwise operator on your original image and you put that mask on top of it, and now you have this imshow with the original colors plus anything you don't want is now in black. Okay, so now it's just time to get the region of interest and then blend in the mask with the ROI. So our final ROI can be calculated by saying CV2 bitwise OR, and in this case we're not going to pass in a mask because we just want to pass in the region of interest and the foreground. And then if you can go ahead and see that final region of interest, notice now that it's pretty much pasted only the red stuff and everything else has been kept intact. And now all we need to do is add this into the rest of the image, and we do that the exact same way we overlaid images on top of each other using that large image is equal to image 1, and then the small image is now equal to that final region of interest. And then we're just going to do the same NumPy indexing we saw in the previous lecture. We'll say large image, starting at y offset, go to y offset plus the small image shape, which in this case is just the final ROI. So small image shape 0, and then we'll say x offset, go all the way to x offset plus the small image dot shape at 1. And we'll set that equal to the small image. So run that, and then let's see the final result. So we'll say plt imshow large image, and there you have it. We successfully were able to put in the do not copy sign without having to worry about that do not copy white background. So that's how we can then watermark our images. I know it's a very complicated process, and OpenCV, this is one of the few things that it really doesn't make easy. Keep in mind, for this sort of thing, you're probably just going to be using normal software like Photoshop or Adobe Illustrator, that sort of thing, but you can definitely check out the notebook. We have 3 really good links that provide additional tutorials on masking in case you ever find yourself having to do this in your own applications. Okay, so please feel free to review the notebook. We have a lot more comments, and definitely check out those 3 links at the bottom of that notebook. Thanks, and I'll see you at the next lecture.